So today I'm going to talk through the solution to the higher level 2019 question 2, which is the relative velocity question. So here's the question. We have a man who's walking at a constant speed in a particular direction, and he has the apparent velocity of the wind. And then we have the woman walking in a different direction with the apparent velocity of the wind as well. So this information is given to us in the question, and we need to kind of record that in some manner first before we can try to answer the question. So here I've got the male. He is walking due east at 4 kilometers per hour. So he's walking from west to east. So I have his speed as 4I, and then the wind appears to be coming from, so the apparent velocity of the wind, or the relative velocity of the wind to the male, is coming from the direction north 50 degrees east. So if we look at north 50 degrees east, this is the direction the wind is coming from. I've just marked the speed of the wind as u. And I can say on this diagram that the angle here is 40 degrees. So we can say that the wind relative to the male is minus u cosine 40 in the I direction and minus u sine 40 in the j direction. So we have here the male's velocity and the velocity of the wind relative to the male, and we can put those two pieces of information together using the formula, which is given here, and that we end up with the velocity, the actual velocity of the wind in this equation here. Okay, we do the same with the information from the female. So the apparent velocity of the wind, as far as the female is concerned, is that it's coming from due north with the same speed. So the velocity of the wind relative to the female is going to be minus u in the j direction. So then we have the velocity of the female itself, and we're told in the question the female is walking towards north 40 degrees west at 4 kilometers an hour. So she's walking towards north 40 degrees west. She's walking in this kind of a direction, 40 degrees being the angle between here. So 50 is the degrees with the horizontal. So she is walking 4 kilometers an hour. So we've got minus 4 cosine 50 in the I direction plus 4 sine 50 in the j direction, giving us our overall direction, our velocity. So again, we put these two pieces of information together with the formula, and we have a second equation for the relative velocity of the wind. Sorry, the actual velocity of the wind. So now we take our two equations for the velocity of the wind and we can equate them. So we can equate the I parts. So 4 minus u cos 40 is the same as minus 4 cos 50, and we can equate the j parts. So that's what we've done here. We've equated the I parts, and that gives us a formula for u, which we can plug into our calculator, and we figure out u is 8.58 kilometers per hour. We then can consider answering the question that was asked. So the question is asking us for the magnitude and direction of the velocity of the wind, the actual velocity of the wind. So we go back to one of our equations for the velocity of the wind, either one of these two, and substitute in that value for u, which we just found. So that's what we've done here. Plug that into our calculators, and we have this as our vector for the velocity of the wind. We weren't asked for the velocity, we were asked for the speed and direction. So we need to get the magnitude of this vector, and we figure that to be 6.08 kilometers per hour, and then get the direction. So this is minus 2.5 in the I direction, minus 5.5 in the J direction. Our wind's actually heading down kind of off in the southwest direction. We need to figure out exactly what angle that is at. So we can use the tan function, and we get the tan is 2.57 over 5.51, which will work out to be approximately 25 degrees. We could have inverted this and got alpha either, which was 65 degrees. So just as we give our solution, we need to state which direction we're talking about. So either we are saying that we're going west 65 degrees south, or we're going south 25 degrees west. Part B of the question then is about some boats. So we have a rescue boat, and we have the speed that this boat is capable of. Currently we're told the boat is 18 kilometers southwest of a particular fixed point P. So P is a fixed point. The B I use for my boat is moving. There's also some current in the water, which is flowing at 4 kilometers an hour uniformly in this particular direction that we've been given here, south 30 degrees east. So I'm trying to take these vectors and put them together in a vector diagram, bearing in mind that the boat is trying to get to the point P as fast as possible. So the fastest way to get to P is actually to actually go directly. So your actual velocity of the boat should go direct from B to P, which means that we want our relative velocity of our boat relative to the current to head off in some other direction where the current is going to pull it back towards P. So from the information in our question, we were told the boat is currently southwest of P, 18 kilometers, so that gives us this 45-degree angle. And then we are told that the current is flowing south 30 degrees east, which gives us the 30 up here, which in turn gives us the 60 here. So we can say that this entire angle is 105. So we're being asked to find the time it takes to the nearest minute to get to P. So we're looking for this boat to actually make it to P in as fast a time as possible. So we're going to use the T method to solve this problem. We recognize that the distance, or the speed, we were told in the question that the speed of the boat, the top speed, so that's the velocity of the boat relative to the current, has a magnitude of 24 kilometers per hour. So if we're going in this kind of direction, 24 kilometers an hour for T hours, we'll actually have traveled 24 T kilometers. That's where this figure comes from. We were told 18 kilometers was the distance away that we were, so we have that figure. The current then flows at 4 kilometers an hour. For T hours will give us this distance 4T. So we can set up our triangle with our distances on our triangle. We worked out the angle from up above as 105 degrees. We can solve this using the cosine rule, which is what I've done here, and then in a few minutes I'll also show you solving it using the sine rule. So using the cosine rule, we have A is going to be opposite our angle A. So we'll have A squared is your 24T to be squared. And then we need that to equal the other two side squares added together. So 4T squared plus 18 squared. And deduct from that the product, twice the product of the sides by the cosine of the angle. So twice the 4T by the 18 by the cosine of 105. When we manipulate this equation, we have a quadratic equation, which is have some pretty horrible numbers in it, but it's still solvable, the quadratic equation in t. And we know that t must be positive. So from this we can calculate t is 0.79 hours roughly, and using the degree, minute and second button on our calculator, we can convert that into 47 minutes and 40.72 seconds, and we round that as requested to 48 minutes. Now alternatively we could have used, on the same triangle, we could have used the sine rule twice. So the first time we choose two sides which both include t, so that the t's will cancel. We include the angle that we know, and we include an angle that we don't know. Now, because we're using the sine rule, we have to use the angles opposite the sides that we're choosing. So I've labelled the angle that I'm going to find first as the angle A, and I'm using 24t over sine 105 is equal to 4t over sine of this angle A that we're looking for. So the t's will cancel, which is what we're looking for, so that we're left with one unknown, which is A. So if we solve this equation, we will get A is 9.26 degrees, or remembering that there is a second solution in the second quadrant because sine is positive there, we'll get an angle of 170 degrees. But of course, we've already got an angle of 105 degrees in this triangle, so it is impossible that we could have a second angle which is 170. So we can discount that possibility. So our angle A must be 9.26 degrees. Using that information, then we can figure out what angle B is, because the three angles will add to 180, and we'll get 65.7 degrees for angle B. We then go back to choose our sine rule again, but this time we only use one of these unknown distances, and we use so the angle that we know, so we must use the 24t to go with it because it's the opposite, so we can't use the 4t, so we have to use the 18, and that will mean we have to use the angle B. So we're going to use 105 degrees with 24t and the B that we just calculated with the 18. So we'll plug those into our sine rule, rearrange it, and we'll get t again, and we use the degree, minute and seconds button on our calculator to convert that to minutes for us. Okay, so that's part one of part B, is to find this time. So the next part of part B introduces a second boat, this time a yacht, and this boat is in distress somewhere near P, and it sends a signal to this rescue boat. So by the time the rescue boat gets back to P, this yacht is 6 kilometers due north of P and is drifting with the current. So P has to try to reach that yacht as quickly as it possibly can. So the diagram for this, we have our boat is at P, our rescue boat, and it's trying to get to the yacht, which is 6 kilometers due north. So we need to get this to intercept with yacht, which is currently 6 kilometers due north away. But the yacht isn't fixed, it's moving, so it's moving with the current. So we have the calculations for the current up above. So we know the current is going to pull the yacht in this direction. We need to reach or intercept that yacht with our boat P, or sorry, the boat which is at point P. So we are going to intercept it as fast as possible or as quickly as possible. So the best way to do that is the shortest distance, and the shortest distance is the perpendicular distance. That's why we have a right angle in here. Okay, so we're being asked to find what time this takes to do this. Okay, so we are recognizing this as a right angle triangle, and we're saying it takes time t to do this. So if we are looking at the relative velocity of the boat to the current, which we have calculated up above. Its speed is 24 kilometers per hour. It's traveling, the relative path is due north, 6 kilometers. So we need to cover 6 kilometers at a speed of 24 kilometers per hour. So that will take us 1/4 of an hour or 15 minutes. So I just want to jump quickly into the marking scheme for this. So I just jump back to part A. Okay, so there are 5 marks going for giving that formula. Okay, so make sure you state that formula of your relative velocity, and then substituting into the formula get you the next 5 marks. Doing the same for the second situation, so you do it for the male and do it again for the female. Okay, and you get your second set of 5 marks for that. Then solving those simultaneous equations get you a further 5 marks, and then finally answering the question with the magnitude and direction get you the final 5 marks. So that's how you clock up your 25 marks for part A of the question. So make sure you state your formula, you substitute into the formula twice, you solve your equations and actually answer the question. In part B, as you can see here, they've given the solution 2 different ways. Okay, so we've got the cosine rule being used on the left and the sine rule being used twice on the right. So you'll get your first 5 marks for the first application of your sine rule and coming up with an angle, or for substituting and simplifying your cosine rule. The second 5 marks is for your second substitution into your sine rule and solving that and coming up with the velocity, which is what they did here on the cosine rule as well. And then your third 5 marks comes for actually calculating the time in minutes as they asked. In part B, then the final 10 marks of the question go for part B. You get 5 marks for recognizing that you can deal with the relative velocity relative to the current, and then 5 marks for actually calculating.